Now we're going to practice what we just learned. So what are we going to do?
Work, work, you see me, I be work, 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 work. You see me do me that. So me better work.
Yeah, I went there. Alright, so I want you to find f prime of x. Pause the video, unpause when you're ready to check. Okay, so hopefully you ended up with f prime of x is 1 minus x squared over the quantity x squared plus 1 squared. Don't multiply that out, by the way. How do we do that? Quotient rule, bottom, times the derivative of the top, minus the top, times the derivative of the bottom, over the bottom squared. And then I just distribute it in the numerator, combine like terms, simplify, yada yada yada, boom, derivative. Next one, find the derivative. Pause the video, unpause when you're ready to check. Alright, here you should end up with y prime equals 5x to the fourth plus 36x squared plus 8x plus 27. How do we get that? I did the product rule. You did not have to do the product rule here. You could have distributed first and then just done the power rule. I chose to do the product rule though, because I wanted to practice the product rule, because that's what we're doing right now, and I feel that that's what I should be doing right now, because I want the practice. So I did the first times the derivative of the second plus the derivative of the first times the second. Then I distributed, combine like terms, and I get my derivative. So no matter whether you did the product rule or not, your final answer should be the same. Next one. Now I want you to find the equation of the horizontal tangent lines to the function f of x equals x over x squared plus 1. We just did the derivative of this 2 examples ago, so you don't need to redo that again. Use what you did already. Pause the video though, find your horizontal tangent lines, unpause when you're ready to check. Alright, so hopefully you ended up with y equals 1/2 and y equals negative 1/2 are the equations of the horizontal tangent lines. How do we come up with that? Good question if you didn't get it. Well, I knew from 2 examples ago the derivative of this function is 1 minus x squared over the quantity x squared plus 1 squared. Alright, so why do I care about the derivative? Because the derivative represents the slope of a tangent line, right? Good, great, grand, wonderful. So then I set the derivative equal to 0. Why did I do that? Because the slope of a horizontal line is 0. So then I solve, which really, remember, if this whole rational expression equals 0, then the numerator has to equal 0, because that's what makes a fraction equal to 0. Now I do have to be careful and make sure that whatever makes the numerator 0 doesn't also make the denominator 0. But in this case, I can see without even doing any work that the denominator would only have imaginary solutions if I was to set it equal to 0 and solve. So I set the numerator equal to 0. I get it x equals 1 and negative 1. So those are the x values where the function will have horizontal tangent lines, but I need to find the y values because the equation of a horizontal line is the y value. Also, just in general, remember when we need to find the point, or I'm sorry, when we need to find the equation of a line, we need a point and the slope. We already know the slope is 0. Now we found the x value of the point, so we plug those back into the original function to find the y values. So I get f of 1 is 1/2, f of negative 1 is negative 1/2. Therefore, my equations of my horizontal tangent lines are y equals 1/2 and y equals negative 1/2, because the equation of horizontal lines is y equals a number. Next one. Find the equation of the tangent line at x equals 1. Pause the video, do that, unpause when you're ready to check. Alright, so hopefully you got the equation of the tangent line is y minus 5 equals 7 times the quantity x minus 1. That's in point slope form. Now, how do I come up with that? Okay, well, first thing I did was, if I know the x value, I need to also find the y value, because we need a point in order to write the equation of a line. Right, good. So I found y of 1, so I plugged in 1, and I get 25 over 5, which is 5. So I know I'm actually looking at the point 1,5. Now I need to do the derivative. In order to do the derivative, I need to use the quotient and the product rule. So that's why I color-coded this nicely for you. I'm sure you love it. So, talk you through it. Bottom times the derivative of the top. Within the derivative of the top, I did first times the derivative of the second plus the derivative of the first times the second. And then I did minus the top times the derivative of the bottom over the bottom squared. See how I color coded that? That's beautiful. It's really pretty. So then that's our derivative. Remember, that's the slope of the tangent line, right? I would not bother to simplify that. The reason why is because we just care about the actual value when x is 1. I need to find the slope when x is 1. So I'm just going to plug in 1 at this point. And I do that very carefully, follow my order of operations, and I get y prime of 1 is 7. So that gives me my slope, so then I can write my equation of a line. Whoops, wrong button. So again, here I didn't simplify because we don't need a simplified version of the derivative, we just need to actually use the derivative in this case. So in those situations, you don't need to simplify, right? And in this case especially, it's not worth it. Okay, so make sure you know your product rule, your quotient rule, and know how to use them.